So let's extend our discussion of relative velocity in two dimensions with the help of umbrella rain problems. Okay, so imagine a situation where the rain is falling, okay, like this. This is vertically downwards, there are no winds at all. Okay, so weather is calm, and then you have to hold the umbrella in this way to protect yourself. Okay, so suppose you are this person and you are holding this umbrella in this way so that to protect yourself from the rain. Now what if the rain comes in a certain direction like this? Like this. If the rain is coming in a certain direction like this, then obviously your umbrella will be held in this way. It will be held like this at a certain angle. Okay, so it will be held at a certain angle to save yourself from the rain. Correct? So now we are going to see one problem where people will ask you what is the angle at which the umbrella should be held when you are moving through the rain. Okay, so the simple case of this is discussed here like this. Okay, a person is moving towards right direction with a speed of 4 meter per second, suppose. Okay, and rain is falling, this is the rain is falling like this, vertically downwards. Rain is not falling at an angle, it is falling directly downwards, vertically downwards with a certain speed. Let's say that the speed of the rain is downwards 3 meter per second. So now let me denote this person's velocity as Vp. So this is Vp bar, and let's say the rain's velocity is Vr bar. Okay, so this is the velocity of rain. Now the question is, at what angle should this person should hold the umbrella to protect himself from the rain? So obviously it is not like this, because if he holds the umbrella vertically upwards like this, then when he moves in the right direction, the raindrops will obviously hit him. So let's see how they are hitting that person. Okay, so if I show you the raindrop, let me select one raindrop over here. We will do with this. I will select one drop and I will move it. Okay, so I am going to move this raindrop. You can see this is a raindrop and it will move downwards because it is already having this vertically downward speed, and it will also move towards the man with respect to the man, because this person will see that raindrop is coming towards him with a speed of 4 meter per second. So for this person, this raindrop is not only moving vertically downwards but also moving in the left direction. So it will come like this in this direction and it will hit him and it will wet that person. Okay, the person wants to avoid that, so he has to put the umbrella in certain direction like this. Okay, wait. So in a certain direction like this. Let me use a pen over here. Yes, a certain direction which should be in this way, somewhat this way. Okay, the person has to use umbrella in this direction. So let's find out what is that direction, and let's find out the velocity of the raindrop with respect to that person. So let's erase this. Okay, and let's find out the velocity of the raindrop with respect to the person. So velocity of the raindrop is downward, which is Vr bar, and velocity of person is towards right. Okay, with a 4 meter per second. So this is the velocity of the person. But now the velocity of raindrop will not be downwards 3 meter per second. Okay, but it will be as well as 4 meter per second also. Okay, 3 meter per second and 4 meter per second towards left for the person, because the raindrop will appear for the person to move towards left as well, right, as well as downwards. So now this is 4 meter per second and this is 3 meter per second. So resultant of these two vectors is the velocity of the raindrop. So if you find out using Pythagoras theorem, it is 4 and it is 3. So the velocity, the resultant velocity will be 5 meter per second. So what is this vector? This vector is minus Vp bar. Why minus Vp bar? Because this is exactly opposite of this vector Vp bar. So this is minus Vp bar. So this resultant vector, if I name it as Vrp bar, it is equal to Vr bar plus minus of Vp bar. So what is it? Vr bar minus Vp bar. But what is Vr bar minus Vp bar? Vr bar minus Vp bar is nothing but the relative velocity of rain with respect to the person. So this is a relative velocity problem. So velocity of rain with respect to person is 5 meter per second. How did you find out that? You just take a square root of Vr square plus Vp square. So you will find out that its speed is 5 meter per second. But now we have to find out the direction in which the umbrella will be held. So now the direction, this, let's say this is the umbrella that is being held and this is its handle. Okay, so now what the handle makes an angle theta with respect to the vertical, suppose. So then if you see this angle theta, then this angle will also be theta. Why? Because it is alternate angle. Okay, so this angle theta can be found out using this tan theta. What is tan theta? Opposite side, which is 5, upon adjacent side, which is 3. So 5 by 3. So theta will be equal to tan inverse of 5 by 3. So this angle with respect to the vertical, at this angle with respect to the vertical, the umbrella should be held to prevent the man from getting wet. Okay,